Last night, while you were completely unconscious, your brain ran a simulation more complex than almost anything it does while you are awake. You were not aware of it happening. You may not even remember it now. But for a stretch of minutes, somewhere in the middle of your sleep, your brain built an entire world of characters, places, conflict, emotion, and you experienced every part of it as real. This is not a side effect of sleep. It is one of the most active, structured, and biologically purposeful things your brain does. So let us walk through exactly what happens inside your brain when you dream, starting from the moment you fall asleep, through the strange neurochemistry that makes dreams feel so real, to why your brain bothers building these worlds at all. Sleep is not one continuous state. It moves through cycles, each lasting roughly 90 minutes, repeating for 2 to 6 times a night. Within each cycle, you pass through stages of progressively deeper non-REM sleep before entering REM sleep. Rapid eye movement sleep are the stage where the most vivid dreaming occurs. As the night goes on, REM periods lengthen. Your longest and most memorable dreams typically happen just before you wake up. The moment you enter REM sleep, your brain undergoes a remarkable chemical shift. Researchers including Dr. Matthew Walker at UC Berkeley have shown that levels of norepinephrine, a neurotransmitter linked to stress and alertness, drop to nearly zero. At the same time, acetylcholine, a neurotransmitter associated with learning and memory, surges to levels higher than when you are awake. Your brain is simultaneously calm and intensely active. This unusual chemical combination is part of what makes dreams feel emotionally vivid yet logically strange. While this is happening, your body is almost completely paralyzed. A structure in the brainstem called the pons sends signals that block motor neurons in your spinal cord, preventing your muscles from acting out what your brain is generating. This is called rematonia, and it exists for a clear reason. Without it, you would physically act out your dreams, which can happen in a rare disorder called REM sleep behavior disorder. Now move to the brain regions actually generating the dream. Your amygdala, the almond-shaped structure responsible for processing fear and emotional intensity, becomes highly active during REM sleep, as sometimes more active than during waking life. This is part of why dreams so often carry strong emotional charge, even when the content itself seems mundane or bizarre. At the same time, your prefrontal cortex, the region responsible for logic, self-awareness, and critical judgment, becomes significantly less active. This combination explains nearly everything strange about dreaming. You feel intense emotion, but you rarely question why a stranger from your childhood is suddenly piloting an airplane through your kitchen. The part of your brain that would normally flag that as impossible has quietly stepped offline. Your visual cortex also activates strongly during REM sleep, generating the vivid imagery you experience, even though your eyes are closed and no actual visual input is occurring. Brain imaging studies have shown that the visual cortex during dreaming lights up in patterns strikingly similar to when you are awake and actually looking at something. Your brain is not replaying old images, it is constructing new ones in real time. So why does your brain do any of this? One of the leading explanations comes from memory research. Dr. Robert Stick Gold at Harvard Medical School has spent decades studying how sleep, and specifically REM sleep, helps consolidate memories, taking fragile, recently learned information and stabilizing it into long-term storage. During REM sleep, your hippocampus, the brain's memory indexing center, appears to replay fragments of the day's experiences, but not in their original order. Instead, those fragments get mixed with older memories, emotions, and unrelated associations stored elsewhere in the brain. This is why dreams often feel like a strange remix of your life. A coworker from last week appears in your childhood bedroom. A conversation from yesterday gets fused with a memory from a decade ago. Your brain is not malfunctioning. It is actively searching for connections between new information and everything you already know, testing associations that your waking, logical mind would never consider. Research published in the journal Current Biology by Dr. Robert Stick Gold's lab found that people who napped and dreamed about a spatial learning task afterward performed significantly better at that task than people who napped without dreaming about it, or who did not nap at all. The dream itself appeared to be part of the learning process, not a random byproduct, but functional cognitive work. A second major theory, championed by neuroscientist Dr. Ani Ravansuo, proposes that dreaming evolved specifically to simulate threats. Under this threat simulation theory, the high emotional intensity and frequent presence of danger, conflict, and chase scenarios in dreams exist because rehearsing threat responses in a safe, simulated environment improved our ancestors' ability to react to real danger while awake. Studies analyzing thousands of dream reports have found that negative emotions, particularly fear and anxiety, appear in dreams far more often than positive ones, a pattern that would make little sense if dreams were simply random noise, but fits clearly with a brain that evolved to rehearse for danger. A third explanation focuses on emotional regulation. Research from the University of California, Berkeley, led by sleep researcher Dr. Ilsvender Helm, found that REM sleep appears to strip the emotional intensity from memories while preserving their content. In their study, participants who slept and dreamed between viewing emotionally charged images showed reduced amygdala activation when viewing those same images again, compared to participants who stayed awake. The dreaming brain, in this view, functions like overnight therapy, processing difficult experiences and reducing their emotional sting without erasing what you learned from them. This may explain why people going through significant emotional stress, grief, or trauma frequently report more intense and frequent dreaming. The brain is working overtime to process emotional material that the waking mind has not yet fully resolved. Now consider what happens when this system is disrupted. When REM sleep is reduced or fragmented through sleep deprivation, alcohol use, or certain medications, the consequences extend beyond simply dreaming less. Studies have shown that REM disruption impairs next-day emotional regulation, increases reactivity to stress, and reduces the brain's ability to consolidate what was learned the day before. People deprived specifically of REM sleep, while still getting other sleep stages, show measurable increases in anxiety and difficulty distinguishing relevant from irrelevant information the following day. So let us reconstruct what is actually happening in your brain during a typical dream. Your norepinephrine has dropped to near zero while acetylcholine has surged. Your amygdala is generating intense emotion. Your prefrontal cortex has gone quiet, removing your ability to question what is happening. Your visual cortex is actively constructing scenes you have never seen. Your hippocampus is pulling fragments of memory from across your entire life and testing unlikely connections between them. Your body is paralyzed by signals from your brainstem, preventing you from acting any of it out. And underneath all of it, your brain may be simultaneously consolidating memories, rehearsing for threats, and quietly diffusing emotional pain from the day before. None of this feels deliberate while it is happening. It feels like nonsense, or adventure, or fear, or joy, arriving without explanation. But the structure underneath that apparent chaos is some of the most sophisticated processing your brain performs in any 24-hour period. You will dream again tonight, multiple times, whether or not you remember it tomorrow. Now you know exactly what your brain will be doing while you are gone.